Okay, so the first thing I'll be explaining is how I got my grid to go from positive to negative on basically, okay. First of all, f prime is going to be explaining basically where the graph is in correlation to the x-axis. So for example, this one is going to be positive because it's above the x-axis, so it's positive. And then this one's going to be negative because it's below the x-axis. And I basically did that for every single one of these. This one's negative, this one's positive, this one's positive, this one's negative. F double prime was a little trickier, but it's basically just looking at the slope in the certain points of the grid. So the slope's going to be going down, so it's negative, still going down, negative, going up, positive, going up, positive, starts coming down again, negative, down, negative. And these little dotted lines are where anytime I got 0, so basically if the slope was 0, like for example right here, or if the y value was 0, so it's right there. Okay, so this question asks, find the x-coordinate of each local minimum at the graph of f. So I'm going to be looking at f prime and where it's going to be switching from positive to negative. I mean negative to positive. So I found that here at x equals -1 because it goes from negative to positive on the f prime. And this one says, find the x-coordinate of each of the points inflection of graph f, justify your answer. So on this one, I'll be looking at the f primes again. And I'm basically just looking to see where there are two negatives or two positives. So, let me see. Oh wait, actually, no. We're switching from negative to positive or positive to negative. I'm sorry. So the first one goes negative to positive here, and that's at x equals -3. And this one equals, it's positive to negative, and that's +3. So that's where I got my answer. And this one says, find all the intervals on which the graph f is concave down, also has a negative slope, explain your reasoning. So first thing I did was look for where I saw concave down, and I found it here. But this side, the slope is going to be going positive, so I'm not going to be using that. But over here, it's negative, as it's coming down from 3. So it's going to be from 3 negative all the way down to 6. And I stopped at 6 because I don't know whether or not it'd be 3 to infinity. But in relation to the graph, it's going to be 3 to 6. Okay, and basically this part right here, I just followed, I don't know how to explain this. I followed what I got up here. So f prime and f double prime. So basically if it said f prime, I don't know how to explain this. But you basically see what I did there. F double prime is like going to be starting off negative. No, f prime is going to be starting off positive. So I go up and then I go down as it changes again. And then I just followed it the whole way. And that's all I did my problems. Okay, so for this problem, I basically did the same thing as the other one. I laid out my grid first and put the dotted lines at wherever the graph equals 0 or the slope equals 0. So for my f prime, this is positive because that's positive, positive because this is still above the x-axis, negative because it's below the x-axis, negative because it's below the x-axis, positive because it's above, positive because it's above. This one, I looked at the slopes again, positive, negative, negative, positive, positive again, and then back down to negative as it curves down. So for the first problem, it's asking, find all the values at x which g has a relative maximum. So basically that's where I'm going to be looking at the f prime, the f prime, to see where it goes from positive to negative. So throughout the whole graph, you can see it goes from positive to negative at -4. So x equals -4 is going to be my answer. And the next problem asks, find all the values at x which g has an inflection point. Justify your answer. So I'm basically looking for when the sign changes at f double prime again. So the sign changes from positive to negative at -6. So that's one of my answers. And then there is another at -2. It goes from negative to positive. And then again at 4 as it goes from positive to negative. So that's how I got that answer. And the next problem asks, find all the intervals at which the graph G is increasing and concave up. So basically I looked at my graph and looked at the points where it would be concaving up and increasing. So basically one of my intervals is going to be 0 to 4 because it's positive, positive, as it shows the slope is positive. And then another one would be -8 to -6. And that's how I got my answers. And then this one, again, I followed my answers above on the grids. I would be going back and forth. But as you can see, this one tells me whether or not I'm increasing, and this tells me whether or not I keep the slope going up or come back down. So for example, this one's going up, so it's f positive, I went up. And then when I saw this, f double prime was still positive, I kept it going up. And then this one was positive, so it's still going, but I didn't follow that. I kind of messed up right here. It's supposed to be going up, and then it's supposed to come down as f double prime happens. And then I basically did that throughout the whole problem. So yeah. Okay, so this problem was a little simplified for me because this was already a graph of f double prime. So basically, so yeah, I just gridded it out and then left my positives and negatives mentally, and I just figured it out from there. So it says state the intervals on which the graph f is concave up. So I was a little confused as to if this would be concave up or this would be concave up. I'm still not entirely sure, but I think this is concave up. And -6 to -2 are the intervals, so -6 to -2, and it's concaving upwards. And then the next one is whether it's concave down, and the next concave down is -2 to 2, so it's concaving downward. If I had these flip-flopped, then I would just switch these, but I'm not sure. But if I'm right, then just leave it as is. And the next thing asks, for which values of x does the graph of f have a point of inflection? Then justify your answer. So basically, again, I'm going to be looking at whether or not, well, since I didn't really write down positive and negative up here, I'm just going to be looking whether or not, where it crosses the x-axis over and over. So one of my answers is going to be -6, -2, 2, and 4. So those should be my answers, and they are. And I justified it by saying f double prime changes signs at each point. And there it is.